At the end of the lesson, you are expected to identify likelihood in machine learning, determine the roles of likelihood in building machine learning models, and appreciate the significance of likelihood in building machine learning models. Now, our model has this form. We have a Tn, but sometimes it could be Yn. It depends on what kind of item you're going to put in here. So is equal to the function of xn with parameters w plus this variable. Okay, so our variable is approximate to a normal distribution of 0 and the standard deviation. So in our past lessons, we talked about this one and also with this one. So this is actually a noise, if you could still remember. And then we also studied about how we are going to find the best parameter that could properly discuss or describe our data. So this time, our concern is this one. So what is the role of this part of our expression? How does this affect this part of our equation? This sounds really very interesting. So if you could still remember, in our lesson before, we studied how to find the optimal value for W. And not only that, not only for W, but then we also talked about the W hat, or the regularized value of W, because our concern was that, and is always, how to identify the loss between our observed data and our model. Okay? We have here an additional parameter. Not only this one, not only this one, but then we've added here the standard deviation. So this is the kind of thing that we're going to set for us to be able to have a better model. And maybe this time you would like to ask me, why do we need to have the addition of the random variable? Also, we had this one in the past, but I think we have to clarify and discuss this one, at least not that very deep, but for you to be able to have a better understanding of why we have this kind of thing. So having a random variable in our expression tells us that the output of our model is now a random variable. So maybe you would ask me at this point, so what would be the effect if the output of our model is a random variable? So in this case, we could see that in every particular value of xn, let me write here, sorry. So in every particular value of xn, there is no corresponding single value of tn. Again, let me repeat that because that's really very important. So it means that for a certain value of xn, there is no corresponding single value of tn. And maybe you would like to ask me, because you're very curious, so why is it that the situation is now like this? Okay, now the reason is that it's because when we add our random variable in this case, then our output would become a random variable. And because it's a random variable, and to be more specific, it is actually a continuous random variable. So if you could still remember, in the first few video of our course, we talked about random variables, we talked about the continuous and discrete random variables. So because it's continuous, we could not find any corresponding value of xn for each output of tn. So because this is the situation, the continuous nature is the case, the effect is that we cannot use the loss as a means of optimizing w and our standard deviation. So the next question would be that what then are we going to do so that we would be able to optimize the value of W and our standard deviation. But before that, before we continue, please hit that subscribe button to enjoy more our deep learning, mastering machine learning algorithm, and natural language processing courses. So in this case, we have to take note that we are talking here of a Gaussian distribution, and then when we say Gaussian distribution, it has something to do with a normal distribution. So we had that in our previous lesson. So because we are talking here of a normal distribution or a Gaussian distribution, what we will do is that we are now going to add our constant, this one. So remember this constant, so we had this one in our previous lesson. So as you could see, each lesson is connected to other lessons. So you have to really go back to our previous lesson if this is your first time to watch this one of the videos of this course, so that you would be able to understand our course very properly. So please go back to our previous lessons, especially from lesson number 1 until this lesson. So do not forget to subscribe. If we are going to add this constant to our random variable, so the result would be that this becomes another Gaussian random variable. And the most exciting part of this one is that the mean is now shifted to the same constant, and later we will have real numbers for that, so you would be able to understand clearly what I'm talking when I say it is shifted to the same constant. So it's because of this thing we now have this new expression to describe our model. Now, because of we have considered likelihood in this case, so we have probability of Tn, that is xn with parameters w and standard deviation, which is equal to the normal distribution of W transpose xn, then we have our standard deviation. So this is actually the density function of our random variable Tn. Alright, now if we're going to examine this part of our equation, then we could see that the value of the density here of Tn would always depend on whatever the value of xn and W in this case. So this determines the mean, and then here we have the standard deviation. This also tells us what the variance would be. Okay, now for us to truly understand what we're talking in this case, we're going to have here real numbers. We are going to apply this to the concepts that we have just discussed. So we are still going to talk about the sales performance we had before. So we are going to consider the same line of thoughts in our examples ever since we started with the modeling thing. So our x is 2015, and our w here, this is w0, this is w1, then this is our standard deviation, 0.05. If we are going to plug in our values here to our equation, then you could see here that we have 1, 2015. So if you could still remember in our lesson before, for us to go to this one, we have to augment every value of x. That is why we have here 1, 2015. But then in this case, this is transpose. Okay? So in this case too, what we do here is that this is a transpose form of this matrix. So we have 34.402, then we have minus or negative 0.0131, and of course our standard deviation, which is I got a mistake, sorry. So our standard deviation is 0.05. if we do the calculation, then we would have 34.402. It's because we have 1 times 34.402, so it's still the same with itself. Then we have minus 0.0131 times 2015. Then if you're going to do all the processes involved here, then we could get 8.0055. So that means the probability here is 8.005 million. I would like to repeat that the P here is actually a probability, and then we are talking here of continuous random variable. But then I would like to remind you that the P here, PT here, does not mean that it is a probability, right? So the value here of 8.0055 million is not actually a probability. And maybe you would like to ask me, what does this value mean? For better understanding, let's have this graph so you could see here the different points, right? So going back to our question just a while ago, so you would like to ask me, what then is the meaning of 8.0055 million in this case if it is not probability? Okay, so this means that the height of the curve at certain value tells us how likely it is that we would observe a certain value of x, or t, I mean, for a certain value of x. So for example, so for 2015, the value is 8.0055. So this means that for 2015, the total sales performance would be 8.0055 million. If we're going to observe our graph, we have here 3 points. We have A, B, and C. Now, what do these 3 points mean? So this is point B, and this corresponds 8.0055. So because it is the highest point and it's almost in the median, then we could say that this is the most likely thing to happen. And here, point C, which is the lowest one, we could say that this is the least likely thing to happen in our sales performance. However, going back to our real data, this is just an example. If we examine the real 2015 data, then we could see that the real value is 8.25. So because it is different, maybe you would like to ask me, what then are we going to do for 8.0055 and 8.25? 8.25 in this case is actually what we call the likelihood of the nth data point. And the fact is that we cannot change this one. We cannot change 8.25. And the best thing to do is that we will go back to this one and we can do something about it. So what we're going to do is that we're going to change W here and our standard deviation so that we can adjust the density so that we can go at least closer to 8.25, if not the exact value of 8.25. What is this for? Why do we have to study this? Having a proper understanding of likelihood in machine learning helps us to identify the probability distribution and the parameters that can really best explain our observed data. Most especially in predictive modeling, in machine learning, this offers a certain framework. It is where we can optimize our model parameters. After all being said and done, let's try this. What is likelihood? What is the value of likelihood in machine learning? Leave your answers in the comment below so that we would be able to have a very rich interaction of ideas and we can learn from each other. Do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning, mastering machine learning algorithm, and natural language processing courses. Learn and upskill for free.